If we consider graphs of the binomial distribution, the larger that the sample size is, the more like the normal curve they become. So for example, if I had a sample size, let's say of 10, and my p-value was, for example, 0.2, the graph of my binomial distribution might look something like that. But as I had a larger sample size, let's say if n equaled 1,000, the graph of my binomial distribution will end up looking more and more and more like a normal curve. And because it does, we can use what's called the normal approximation for a binomial distribution. So what we need is we still need a binomial case. And to have a binomial case, remember, you need to have a probability of a single outcome that doesn't change, and you need to make sure every case is independent of the next. You also need to make sure you only have a success or a desired outcome or a failure or a non-desired outcome. Then what you do is you start off in binomial land. And using the values you have, where you'll know what your number of trials is, and you'll know what your possibility or probability of success from a single trial is, you work out your mean by using NP, and you work out your standard deviation by the usual formula. And then what you do is you get these two values and substitute them into a normal curve. So you get your binomial values for mean and standard deviation, but you process them as though they are part of the normal distribution to get your answer. So let's imagine I had 1,000 people in a certain sample. And remember, I need it to be a large sample. So I've got 1,000 people. And let's say the probability that they were left-handed was 0.15. Then what I could do is work out the standard deviation and the mean of that using my binomial data. So remember, with binomial, I would find the mean would be n times p, and my standard deviation would be the square root of n p and then 1 minus p. Then what I would do is use these numbers and put them into the normal distribution. My mean here will be 150. And my standard deviation is about 11.3. And then I would use the normal calculations to find out, for example, what are the chances that in a sample of 100 people, I will find between 100 and 250 left-handers. So I would get out my normal calculator and I would say my lowest value is 100. My upper value or my high value is 250. I have a standard deviation of 11.3 and a mean of 150. And using normal distribution on the calculator, I would find the probability of having between 100 and 250 people, left-handers, considering this according to the normal distribution, is 99.9995% or 0.999995. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.